In this video, we're going to look at quite a convoluted and quite a tricky question in Euclidean geometry, and so I hope you appreciate all the flavor that comes out of it. For the purpose of this video, I'm not going to write down every single reason that I put, although in an exam you would. I'm just going to discuss it with you. I'm going to let you into my mind of how I would approach a question like this, which is primarily as I read information, I try and fill in. In the diagram below, there are two circles that touch externally at P. QPR is a tangent to both circles, and so immediately I'm just going to pause and say if this is a tangent, then if here's the angle, then I go opposite and outside, and that would also be a X. And while I'm on a roll, I would then say that P5 is equal to X vertically opposite. If this is a tangent to this circle as well, then if that's X, I'll go to the side, to the chord that it hits and go opposite, and that should also be X. I could have got that because of these parallel lines being alternate, but that's just to show you that. Just from the word tangent. EDRC is also a tangent to this circle, and so what you've got is if this is Y and it hits into this line, then the angle opposite this chord, PC, will also be Y. The other thing that's jumping out for me is if I've got a tangent here and here, then these two lines should be equal, and so that's also going to be a Y. And if that's a Y, if you want, you could do vertically opposite to get that Y. And so my picture is just becoming a lot more colorful because of everything that I've filled in already. I haven't even got to the question. And then they say that DAC is X, and so a quick thing that's buzzing in my mind is if this is X, I can follow along with my fingers to the chord opposite, which is DP, and I bounce off that trampoline, that chord, and I end up here, and that will also be X, angles in same segment. So all of that's been filled in. I could fill in other stuff, but I'm just going to pause my excitement to just look at what the questions are asking and see what I've actually done. Name with reasons 4 other angles equal to X. So we've got 1, 2, 3, 4. So we've already got that and discussed that. Show that EPA equals X plus Y. Let's just say you couldn't get this answer. Then it's good to, in the next question, say assume that it does equal X plus Y, because that will help you to probably continue with the questions after that. And so there's often lots of ways to get your answer. It's nice if you do find a quick one. And so EPA, which is basically P7. And what you could do is you could try to do sum of triangle here. You could try to see what other vertically opposite you can do. What I'm noticing is that I've got a big triangle over here, and so if you want to redraw in the noise, which is great advice when things get a bit busy, I've got an X in the corner and I've got a Y in this corner, and they're wanting me to work out this angle here, and so it's just the exterior angle of triangle. So actually in one step you could have got the answer and said this equals this reason, exterior angle of triangle ECP. So now I know that this is X plus Y. And again, I won't rush into it, but my brain's thinking the opposite could also just be vertically opposite. P3 is X plus Y. Determine the numerical value. That just means a number for X plus Y if it is given that DCTP is a cyclic quad. And so we've got DCTP being a cyclic quad. And if that's a cyclic quad, you can't say, no, it's not inside a circle. It means that we can use all the normal properties of a cyclic quad. We don't have lines crisscrossing from side to side, so it's probably not angles in same segment. So then the best use is probably to do the opposite. And so this angle, again, you can redraw this in seconds and see that in this corner here by C, we've got an X and a Y, so X plus Y. In this corner here, we've got an x and a y, and then we can now do our vertically opposite, and so we would end up with 2 x's and 2 y's. So I'm a huge fan of just on your question paper redrawing in seconds shapes that you're working in, because then when you get to something that feels really left field and confusing, you can just say the opposites should add up to 360 to 180 in a cyclic quad. So opposites add up to 180, so that would mean 3x plus 3y equals 180, sum of opposite angles in a cyclic quad. And so if you want to work out a value for x plus y, you just divide everything by 3, and suddenly you've got an actual value, even though when you looked at the question there were no numbers anywhere. And so that's how I would approach a really complicated question like this. I hope that you found that helpful. If you did, please like this video, subscribe to our channel, and share this with your friends. Thanks.